Evening, students. This is another review for the final. Um, we never actually took this test, but I wanted to use this as part of our study guide. So let's just go through this and uh, get better at doing all kinds of things with functions and graphing and solving symbolic functions, equations of parabolas, which are quadratic equations. Okay. Okay, so the first one says match each equation below to the resulting transformation of the parent function. That's the parent function. We always know that, right? The x squared is the parent function. Over here, I made a mistake when I was going through it. So they're asking which one was translated, meaning which parabola actually moved up or down. Okay, so in this case, this one moved down 6. The vertex moved down 6 units on the y-axis. So I selected this one. I didn't actually know what I was doing over there. So I crossed that out. This is actually the right answer. H of x equals x squared minus 6. So over here, the explanation is slide down the vertex. Let me say it like this, down vertex by 6 units on the y-axis, okay? Oh, I said down here. Anyway. Okay, dilate, stretch. That means you're going to have like an integer as a coefficient in front of the x squared that is not a fraction, a whole number. So that'll make the parabola extremely narrow. Okay, so the only one that matches that description is m of x. This is m. I know it's hard to read, but that's m of x. Okay, m of x, which is the 3x squared. So with the 3 in front of the parent function, the parent function is going to be stretched. So they call it stretch right here, dilate, stretch. To be very narrow. Okay, right there, that's description, to be very narrow. Now the next category is dilate, compress. And we know that to be, if there's a if there's a fraction in front of the x squared, something in between 0 and 1, the value between 0 and 1, the coefficient is going to be compressed, very flattened out parent function, okay, compressed, okay. And we also know that if we see a negative sign in front of the parent function, it'll be a reflection and it'll open downward, okay, it'll open downward, okay, very good, very good. Now next, number 2, compare and contrast. So you need to show what is similar and what is different about the two functions that are given. In this case, I take a look at it. I notice there's the same coefficient, except one is a negative sign. Also, it's x to the second power, both functions, so I know that. Okay. The difference is the negative sign. So like we were mentioning, anytime you see a negative sign, you would reflect over the x-axis. It'll be a mirror image reflected over the x-axis. So g of x would look something like this, with a stretched parent function, parabola. The h of x would be reflective of that, but it'll be a negative, so it opens downward. Okay? Okay, how about the next one? C of x is x squared minus 7. d of x is x squared plus 2. Okay, this is not correct. That is not correct. And that's why I redo these videos every so often. Do you see my mistake? Okay. Oh boy. This is a little bit embarrassing, but let's make the corrections, okay? So I'm going to do it here, where I have a big open space. Let's do it there. Okay. Here's the general graph. X-axis, y-axis. This one says c of x is x squared minus 7. Okay. Same variable, same exponent, but look, the shift, the translation is different values. Okay. One is negative 7, one is plus 2. Okay. Now, this is no good. I don't want you to look at that. That's a boo-boo on my part. So, okay. Look, x squared, that's the parent function. X squared is a parent function. So the only contrasting differences between the two are the shifts of negative 7 and positive 2. Now these describe the shifts up and down the y-axis. So this could be like a negative 2 here. I mean a positive 2. Positive 2. Okay. Something like this. Okay. So this would be your the d of x. Now where would the c of x be? It'll be slid down 7 units from 0, 0. So the vertex is going to be down here. 7 units down. Let's say 7 might be over here. Okay. Okay. Let's draw the parent function now. It's still the same parent function. Not any skinnier or more narrow or compressed. It's not dilated. All what is did is shift up and down the y-axis from 0, 0. Okay. Sorry about that. Okay, now let's get on to number 3. Number 3. Okay, your friend is having trouble graphing the parent function. Explain to your friend how to go about graphing f of x equals x squared. Then graph the function. Well, the parent function is exactly this. F of x equals x squared. How do you graph it? Well, this is what I do. I make a little table. Make a little table. It's not an equal sign, actually. X. Okay. So here's my table. So if I plot the points, if I inserted 0 in for x, my f of x will also be 0. If I insert 1 for x, my f of x, the y value, it also will be 1. 2, I'll get 4 over here. Because 2 squared is 4. How about negative 1? Let's try. Negative 1 times negative 1 is 1. So the answer is 1. Negative 2, if I plug that in for x, negative 2 times negative 2 is 4. And then I would just plot these functions right here. These points, see these points right here? Okay. All right. So I hope you guys got that. Don't be alarmed by my messy correction there. Sorry. Okay, moving on. This is why I double check. Double check, double check. Okay. Okay. Now in this section it says describe f of x equals x squared with will be transformed for each function. Use the terms translate, dilate, and reflect when appropriate. Then sketch the graph of the function. The parent function f of x is equals x squared is already drawn. This one right here. Parent functions are already drawn. Okay. So now let's take a look at A. It says 1/2 x squared minus 5. Okay, I see two things that's going to change right here. The 1/2 is a dilation because it's a fraction between 0 and 1. It'll compress. It'll be flattened out. Okay, it'll be flattened out. And this -5 will tell me it drops down 5 units on the y-axis. That's what that's for. Okay. Okay. Oh my gosh. Okay. How about b of x? 3x squared minus 1. Transformations, I can see a dilation, a stretch because it's a whole integer. It'll be very narrow. The 3 will make the parent function very narrow. The -1 will drop the vertex 1 unit down the y-axis. Okay, so it'll be right there. How about c of x? C of x minus x squared plus 4. Okay. Reflection, translate. This is a reflection, so it opens downward. And 4 tells us that the vertex slides up 4 units on the y-axis. Okay. 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 Now the next one. Write the symbolic representation of each function given the transformation on the parent function f of x equals x squared. Okay. Now they want us to come up with the function. So let's do that. Something that's dilated by the factor of 2, which means the coefficient is going to be 2 in front of the x squared. This is the parent function here. Dilated by 2, and we put the 2 right in front of x squared. Translated up 6, you're going to add 6. The vertex is going to slide up the y-axis by 6 units. Okay. How about this one? Dilated by a factor of 1/4, translated down 9, so -9, reflected over the x-axis. It means it should be a negative sign there. Okay? So just take each one of these transformations one step at a time, and you'll be fine. Now remember, if you don't know what's going on, you can always plot the points and verify if your equation is correct or not. Plot the points if that helps you, okay? You can always verify. Okay, number 6. Based on 5 points shown in each graph, determine the symbolic representation of each function. Okay. So we just have a parabola with some points, and we need to come up with the function. Okay. First thing I notice is the vertex has shifted down 1, 2, 3, 4 units. And the next thing we have to ask ourselves is this a Is this a parent function? No. Okay, let's see. So a parent function, I know just from experience of this one here, the parent function would have these points: 0, 0, 1, 1, 4, 2, 1, negative 1, 4, negative 2. In this case, you gotta really use your brain, okay? Now you see this function. So the 1, 1, see that 1, 1 over here? Or the 0? The 0, 0 would translate, okay, that's the 0, 0, okay? Now you have the 1, 1, which is the point right here. And the 1, negative 1, which is the point right here, okay? So what we just did is kind of drawing our parent function. The next point is 2, 4 and negative 2, 4. You know, 2, 1, 2, 3, 4, and negative 2, 1, 2, 3, 4. So the blue graph that we're showing here is a parent function. So let's just call it that. Okay, which is f of x equals x squared. Now, instead of 1, 1, for each value of x, the y has jumped by 2. Okay, now how about this one? If the value of x is 2, then the y value would be 1, 2, 3, 4, 5, 6, 7, 8. 8. So for the value of 2, usually the parent function will give you a y value of 4. But in this case, for x equals 2, this value is 8. Okay? So you go 2, 1, 2, 3, 4, 5, 6, 7, 8. So you know that you have a transformation here, which is a dilation of the parent function. So this r of x is this. The blue is the parent function. Sorry, I kind of messed it up. I should have made it all color coded, but the r of x is there. The r of x, okay, which is this. I hope you can see for each value of x, normally it would be 1, 1, but in this case it's 1, 2. So I know the x has been multiplied by a value of 2. If x is 2, the value is 8. Go 2 and then 1, 2, 3, 4, 5, 6, 7, 8. So again, it was multiplied by 2. Normally the parent function for x is 2 is you go up 4 units. 1, 2, 3, 4. But this is not the parent function. This is r of x, which is a slimmer, more narrow, we call it stretched parabola. Okay? So this is the function, the symbolic representation of that function. Let's take a look at b. First thing I notice, it's opening downward. So I know it's going to have a negative sign there. Is it a parent function? 1, 1, 2, 1, 2, 3, 4. Yes, it is a parent function. So let's see. Excuse me. Just to highlight, this is a parent function. Okay, it's a parent function. So that being said, it's a parent function. It's reflective over the x-axis, but the vertex is at positive 3, reflecting downward. Okay, and that's all we have to do for that one. Oh boy, look at this. Okay, let me just finish my drawing here. Okay, how's that? Okay. So as you can tell, I worked on this a little bit before putting this video together. Apply what you know about the value of A and C affect the parent function to graph the quadratic function negative 2x squared plus 5. Okay, we're talking about this one right here. It opens downward and the vertex has been translated up the y-axis 5 units. 1, 2, 3, 4, 5. So it looks like that. It's not a parent function. It's 2 times the parent function. Do you see that? Okay. So moving on to number 8. It says use the graph f of x equals x squared minus 9 to solve each equation or inequality. Briefly explain how the graph supports your answer. Okay. This is one of the hardest areas of inequalities and graphing of parabolas that you're going to come across. So let's go step by step. It needs 100% focus and concentration, or not you're going to miss it. You're going to miss it big time on the test tomorrow. Okay. Okay, let's go through it. All right. Now for A, x squared minus 9 equals 0. So we have the graph here. X squared minus 9 equals 0. This is the graph x squared minus 9. Okay, this parabola right here, and I kind of drew like extensions of this parabola that goes on forever. This goes on forever right here, just to emphasize some of the values over the x-axis. Okay, so what's going to satisfy this equation here? X squared minus 9 equals 0. Well, it's going to be 3 or negative 3. So we have the 2 points crossing the x-axis right there. So I want you to see the connection. The 3 and the negative 3 are the points where the parabola crosses the x-axis. And those are what you call the solutions to x squared minus 9 equals 0. Okay? Now, for B, when you have an inequality here, x squared minus 9, all values x squared minus 9, which is less than 0. Pay attention, guys, or not you're going to miss it. So this being the parabola, the sign here is less than. What's less than this value here? What's less than the x-axis? What is negative values here? When looking at this parabola, what are the negative values? Well, it's going to be between negative 3 and 3. Okay? Between negative 3 and 3. These are all the negative values of the function of x squared minus 9. So all values that satisfy this inequality would be okay. And it falls all between negative 3 and 3 on the x-axis. Okay? Okay. I know it's hard to get this. You got to really pay attention. You really got to think it. You cannot cheat it through to understand it. There's no way you're going to accomplish that. Okay? So try to understand it. If you don't understand it once, take 2 times, 3 times, 4 times, 5 times. Talk with your friends until you get it. Until you get it, okay? Go over Khan Academy if you have to. See if they have a similar problem solution, okay? Just go over it over and over again and see if it makes sense. All right, moving on. X squared minus 9 is greater than 0. the key term is greater than 0. So the whole f of x is greater than 0. So what is greater than 0? It's up here. All these values here. All these values here. From here up. Not here below. Here up. So when we look at the chart, what's going to satisfy this? X got to be greater than 3. Then it's going to be greater than 0. So all values greater than 3 on the x-axis. All values greater than 3. And also, what also will also satisfy this inequality, greater than 0, which is all these values here, would be x is less than negative 3. If you substitute that back into the equation, negative 3 meaning like if x is negative 4. If x is negative 4, this would be 16. 16 minus 9 will be 7. 7. Oops, wait. Oh, I'm looking at the wrong one. Oh my. Oh boy. Okay. X is greater than 3 works. X is less than negative 3. Okay, right here. So negative 4, for example, would be 16. 16 minus 9 is 7. 7 is greater than 0. So all these values this way, all these values this way. Okay? See, it's not hard, but you cannot miss a single detail, right? You cannot miss a single detail. Okay, number 9. Use the graphs provided to solve each equation or inequality. The first one, A, x squared plus 4 equals 5. Okay. This is an equality. So where does it cross the x-axis? Right there. X equals negative 1. X equals 1. Okay. These are the solutions to this function right there. It's the same function, they just kind of moved around some of the terms. This one is no solution. You can see because the parabola does not intersect the x-axis. Oh boy. Okay. There's no solution. And for the last one here, x squared plus 3 is less than 7. Okay, we can also write this as x squared minus 4 is less than 0. Okay. Subtract 7 from both sides of that inequality sign. Then we get x squared minus 4 is less than 0. The reason why we're looking at zeros is because we can see that there are 2 points here where the parabola crosses the x-axis, which is 2 and negative 2. Okay. So again, just like the problem above here, like here, you see this dip right there? Those are the negative values of the parabola from the x-axis. So this one would be similar in that light, except for these points are going to be negative 2 and 2. Negative 2 and 2 satisfies this equation right here. For example, if this was negative, let's see. Oh, this is in between. I'm sorry. This is in between negative 2 and 2. So if this was 0, substitute back into the equation. If that was 0, which is right there, 0 minus 4 is a minus 4. It is less than 0. So I think we understand that this is a solution to the equation, the function. Okay. So the values between -2 and 2 are the values on the x-axis that will fulfill this function right here. Okay. And that is it. So good luck to you guys working on this study guide and the next study guide that I gave you last Friday or Thursday, depending on which period you're in. Use both study guides. Both of them will make you stronger in preparing for the exam. Uh, so good luck, and I'll see you tomorrow. Tomorrow, first thing, come into the class because it's going to be a long exam. I'm going to give it to you as soon as you come into the class. Get settled down immediately. Anybody who straddles in late, well, they'll have less time to finish the exam. So you don't want to be that guy. No. Okay, good luck and see you tomorrow.